All right, so the reason that these problems are a little bit different than the ones that we did yesterday is that yesterday it was very basic in the sense that there was supposed to be an inside function and there was supposed to be an outside function. And you took the very basic derivative of the inside function and you took the very basic derivative of the outside function and you just multiplied them together. Okay, so that was day one of the chain rule. I wanted you guys to get used to using the chain rule. Today is a little bit different. Today is a little bit more difficult because we are throwing in a little bit extra on top of the chain rule and we have to use other rules in addition to just the chain rule. Sound good? Cool. So here's what we're going to do today. Oftentimes I will ask students, like in years past I've asked students, what do you see in this function? And I haven't really clarified what I meant when I asked that question, when I say what do you see? And so people will literally just start reading to me what they see. And they'll be like, okay, I see x squared, I see 2x, I see a minus sign. That's not what I mean. I can read too. So I know that that's what you see, but I guess what I mean is I want you to interpret what you see. So let me model for you what I mean for the first one, and then I'm going to have you guys do it for the second one, and then tell me back what you see. So, do you guys see this list over here on the board? We have some words listed over here on the board. We have the word function, we have the word multiply, we have the word divide, composition, product rule, quotient rule, and chain rule. All right? So, when I look at these problems, and again, you don't have to verbalize it every time you do a problem, but this should be going through your head when you see a problem. I want you to tell me what you see in terms of using these words, and then I want you to interpret what that means in terms of taking the derivative. Okay? So let me model the first one for you. If I'm looking at the first problem, look at the first problem with me. I see two functions, that's our first word. I see two functions being multiplied. Do you guys see two functions being multiplied? All right, what's the first function? And what's the second function? 2x minus 3 to the fourth power. So I see two functions being multiplied, all right? Which means when I take the derivative, I need to use the product rule. All right, do you guys see what I mean when I say use these words? I see two functions being multiplied, so when I take the derivative, I need to use the product rule, okay? Now, within the second function, the orange one, within the second function, I see a composition. What do I mean when I say a composition? Not the quotient rule. The chain rule. We're going to have to use the chain rule. What is a composition? It's a function within a function. All right? It's a function with a function inception. All right? This is a composition. What is the inside function with this orange one? 2x minus 3. What is the outside function? I to the fourth power. Do you guys see a composition? So here's what I'm seeing. When I ask you for the next one, what do you see? Here's what I'm looking for in return. I see two functions being multiplied together, which means I have to use the product rule to find its derivative. And when I find the derivative of the second function, I have to use the chain rule because it's a composition. Okay, so take 30 seconds, and in your groups, I want you guys to discuss what you see for number 12. So tell me, what do you see in number 12? I see two functions being divided. So when I take the derivative, I need to use the quotient rule. Okay, what else do you see? Good. I also see a composition of functions, which means when I take the derivative, I need to use the chain rule. All right, now look up here. Very carefully look up here. Well, you don't have to carefully look up here, but look up here. And pay careful attention is what I meant. It depends which one you need to use first. All right, so for this one, we're going to use the product rule first, and then we're going to use the chain rule inside of this second derivative because the chain rule didn't apply to x squared. Which rule do we use first here? This time we're using the chain rule first because the chain rule applies to the derivative, division problem. All right, the chain rule applies to the entire division problem. So we're going to use the chain rule first here, and then inside of the chain rule we'll have to use the quotient rule. Sound good? Yeah. Okay, so we're going to do this one together. We're going to set up the product rule, and then you'll notice that inside of the product rule we're going to have to also use the chain rule. So product rule says identify u and identify v. So let's do that on our papers. U equals the first function, so shout it out. What is u? X squared. And v equals the second function, so what's v? 2x minus 3 to the power of 4. All right. U equals x squared. The derivative of that is fairly simple. What is the derivative of x squared? 2x. U prime equals 2x. V prime is the one that we need to use the chain rule for. So if you would like to write it out, write it out. If you don't need to write it out, don't write it out. But find the derivative of v really quick using the chain rule. All right, the derivative of 2x minus 3 to the fourth power using the chain rule. The derivative of the outside function is 4 times the inside cubed. So that's 4 times the inside cubed times the derivative of the inside. And the derivative of 2x minus 3 is just 2. How can I simplify that? Yeah, the only thing I can do is rewrite it as 8. I mean, technically I could multiply out 2x minus 3 cubed, but that's honestly a waste of time. They will never make you do that. So 8 times 2x minus 3 cubed is the only way I can simplify that. So now that I've done that, we can continue with the product rule. So the product rule says take the derivative of the first function and multiply it times the second. So we have v times u prime. So y prime equals 2x times 2x minus 3 to the power of 4. That's from right here. Plus 8x squared times 2x minus 3 cubed. And that's from the first times the derivative of the second. Alright, now I've told you this before and I'll tell you guys again. The problems we do in class are more difficult than the ones you're going to see on the AP exam. Okay? So, I'm not saying that you're never going to see difficult problems on the AP exam. I'm saying that not every single problem on the AP exam is going to be difficult. The reason being is because you only have an average of 2 minutes per question. Already we've spent like 4 minutes on this question. Okay, so obviously we're first learning it and you will get faster, but it's going to be difficult to do questions that are at a higher level in 2 minutes, which means that not every question is going to be super difficult. So please don't ever feel overwhelmed by the level of difficulty you see in class. The reason I do it now is so that you guys get really good at these problems, so that down the line when you see the easier ones on the AP exam, they seem easy to you and you don't get stressed out about it on the actual AP exam. So from here, technically this is a correct answer. You guys okay with that? Technicality. So if you had a free response question and this is what you were asked to do, technically this is a correct answer, so we would have no problems with having this as our final answer. However, on a multiple choice exam, they're going to look for a greatest common factor, a GCF, and they're going to try and factor it out. So read through it with me. This one has a 2. Can we factor a 2 out of the second term? Yeah, because 8 also has a factor of 2. This one has an x. Can we factor an x out of the second term? Yeah. Also x. So far we have a 2 and we have an x. This one has the quantity, 2x minus 3. It has it 4 times. Does this one have any 2x minus 3s? Yeah. How many does it have? 3. So we can factor out a 2. We can factor out an x, and we can factor out the quantity 2x minus 3 a total of 3 times. So that's our GCF. So do me a favor and write all those out front. We can factor out a 2, we can factor out an x, and we can factor out the quantity 2x minus 3 times to the power of 3. And then let's see what's left over after we do that. From the first term, we factored out a 2. So 2 divided by 2 is 1. That one went away. From this one, we factored out an x. So x divided by x is 1. That went away. And then from this, we factored out 2x minus 3 to the power of 3. So if there were 4 and we factored out 3 of them, that means there's 1 left. Yeah. You guys okay with that? So the 2 went away, the x went away, and then all of them except for 1 went away from this. So we still have a 2x minus 3 left from that yellow term. So I'm going to write that in here, 2x minus 3. There's one of those left. And then from the orange one, we factored out 2. So what's 8 divided by 2? 4. So there's 4 left there. We had x squared and we factored out one of those x's, so there's 1 x left. And then we had 2x minus 3 to the third power and we factored out all of those. So that entire thing went away. So we're left with 4 times x to the first power. So plus 4 times x to the first power. So the only thing we can do is we can simplify what's inside of those second set of parentheses. So we have 2x times 2x minus 3 cubed. And then what does that second set of parentheses simplify to? 6x minus 3. Beautiful. So they'll never really ask you to multiply out things. Like they'll never ask you to multiply out 2x minus 3 to the power of 4. But they definitely would factor it out as a GCF and write it in simpler forms that way. And you'll notice that, by the way, on your homework tonight, you guys are going to come back, and I know for a fact you're going to ask me questions, and you're going to see my answer, and you're going to be like, I didn't get anything that looks like that. But again, you may write it in a different way, but it could be equivalent to my answer. So we just have to be patient and look through to make sure it's the same. All right. I want you guys to try the next one, number 12. So you guys wrote down number 12 also, correct? Yeah. I want you guys to do that in your group. Find the derivative. All right, so what is the inside function in this one? 2x minus 1 over 2x plus 1. Beautiful. What's the outside function? I to the 5th power. All right, what's the derivative of the outside? That one's easier. Beautiful. 5i to the 4th power. So I just replaced I back with what it equaled again. 2x minus 1 over 2x plus 1. What is v prime? We have to use the quotient rule, huh? Yep. All right, now here's what I mean when I say I'm going to stop writing every single time. I'm going to stop writing out the u and the v. So I'm essentially going to ask you guys to start doing it in your heads. So for the quotient rule, you do the derivative of the top times the bottom. So what is the derivative of the top? 2. The derivative of the top is 2. And then so we're going to do 2 times the bottom. So the first thing I'm going to write is 2 times 2x plus 1. Minus the top, so 2x minus 1. Times the derivative of the bottom. What's the derivative of 2x plus 1? 2. So that's minus 2 times 2x minus 1. All over what?
The bottom squared.
Good, the bottom squared. So 2x plus 1 quantity squared. All right, so far so good? Did you guys take a chance to simplify the numerator of that fraction?
Yeah.
What'd you get? 4. Beautiful. So if I multiply, I actually get 4x plus 2. Oh, there went everything. Try that again. If I multiply, I actually get 4x plus 2 minus 4x minus 2. Plus 2. And so that adds to 4. So if I simplify that, I get 4 over 2x plus 1 squared. All right. So when I do the chain rule, I do the derivative of the outside times the derivative of the inside. So the derivative of the outside is 5 times 2x minus 1 over 2x plus 1 to the 4th. And the derivative of the inside is 4 over 2x. Oh my goodness gracious. 4 over 2x plus 1 squared, like that. Now, remember earlier how I said our answers may vary? If you got up to here, that's great. That's absolutely correct. But I'm going to try and show you what I think it might look like on an AP exam. So on an AP exam, I think they're going to multiply 5 times 4, which is 20. And I think they're also going to recognize that we have a 2x minus 1 on the bottom of both of them. This is 2x minus 1 to the 4th power. And this is 2x minus 1 squared. What do you get when you combine 2x minus 1 to the 4th and 2x minus 1 squared? 2x minus 1 to the 6th. So I think they'll split up that fraction and give the 4th power to both of them, and that way they can combine the denominators of both of them. So I think that's what it looks like on the AP exam, but this is also a correct answer. So my question is, can you figure out that this is the same thing as this? That's the test. Can you figure out that these two are equivalent to each other if you were given this as an answer choice? All right, so let me ask you guys what questions you have then. Okay, let me come back. Let me step back a step. Raise your hand if you got to here. Raise your hand if you got this far. Okay, so most of you guys got this far. Raise your hand if you wrote your answer like that. Not very many people. Okay, those of you guys who got to here but didn't write your answer like this, do you know how to write your answer like this, or do we have questions about how to write your answer like this? So, do you have a specific question? Like, do you know where it's messing you up?
I mean, I don't really think of 4, like, distributing to the bottom, so I guess that's probably why.
Okay, so then let me ask you this question. If you got this on the AP exam, it's a multiple choice question, you got this on the AP exam, you look at all the answer choices and nothing looks like this, what would you do?
I would probably try to simplify more.
So you don't guess, you try to simplify more. Alright, so I guess my suggestion is to start looking for pieces that look similar. Like if you have this, but it didn't look like an answer choice, but you recognize that 5 times 4 was 20, if some of your answer choices had 20 in them, start to look at that. And then if you realize that it had 2x minus 1 to the 4th power, realizing that this was 2x minus 1 to the 4th power, and then start simplifying that way. So use your answer choices as a way to guide you toward a correct solution. So it is an art, it is a skill that kind of takes some practice, but the more you practice, the better you get. Which is why, even though I tell you this is the correct answer, I don't suggest leaving your answer like this, unless you feel very comfortable doing the next one as well. All right, we're going to do one more type of problem. So we're going to do another type of problem that we're going to talk about, and then we'll do one more type of problem that we actually write down. So let's do the talking about one first. I want to talk about this one. Take 30 seconds in your groups, and using these words right here, tell me what you see. All right, now tell me, what do you see? I see two functions being multiplied, which means when I take the derivative, I need to use the product rule. What's special about the second function? It's a what? It needs to use the chain rule, but it is a what? It is a composition. It is a composition of two functions. What's the inside function? X plus 2. What's the outside function? I to the 1/2, or the square root of I. Beautiful. So when I do the product rule, I need to use the chain rule in taking the derivative of that second function. All right. I want you to write down, well, first of all, this one. I see two functions being multiplied. When I take the derivative, I have to use the product rule. For this one, I see two functions being divided. When I take the derivative, I have to use the quotient rule. On this one, I see a composition, a function inside of a function. So I have to use the chain rule. This is a composition, a function inside of a function. I have to use the chain rule. I think that you guys can do all of these. The one that may trip you up is 18. So I want to see you guys do 18. So this is the last problem of the day. So write down 18. Take the derivative using the chain rule. Plug in the numbers that are given up there in the directions. And then I'll go over the answer in just a minute. Here's the answer. So the inside function is f of x, the outside function is I cubed. Take the derivative, and multiply them together. F of 2 is equal to negative 3. F prime of 2 is equal to 6. So negative 3 squared is 9. Times 3 is 27, and 27 times 6 is 162. All right, your homework tonight is to finish the rest of homework number 8. So finish every single problem. I'm halfway through it. I'm going to finish the rest of the solutions during 4th period, and I'm going to send them out to you guys in school loops so you guys can check your work before you come to class tomorrow. Again, please keep in mind that your answers may look different than mine, and that's okay. So if you have questions, just ask me tomorrow.